Thank you, everybody, for participating and joining us on this Autodesk Eagle webinar. My name is Edwin Robledo. I'm part of the global support team, and joining me today is
George Garcia. I'm product support specialist for Eagle here in the Americas.
the intention behind of this webinar today is to teach the community how to use the legal library editor. There's a plethora of material out there when it comes to Eagle libraries. Contributions made by the community, contributions made, some of it by us as well as many websites that provide Eagle libraries. But in essence, you always have to check those libraries, and hopefully, by dissecting how do you create components using the Eagle library editor,
Mhm.
we'll also teach you how to verify that the components that you wanting to use have been done correctly. Okay, so Jorge is going to be taking over on this, and I'll get back to you. So you're going to notice a little blink on the page. Oh, I wanted to view the votes. So apparently we have approximately the majority of the people here have been using Eagle occasionally, so they have some experience, and we have a couple of experts as part of the team as well. So thank you everybody for taking the poll. Gives us an idea of how fast we could go. Now we're going to be switching over to our presentation screen. I have some definitions. Um, you could go ahead and start sharing your screen. So I have some definitions posted up on the top right-hand corner. These are some topics that are going to be showing up throughout the presentation, so you can make reference to. Now, during the chat, you are welcome to, during the presentation, you're welcome to post any questions on the general questions chat that we have there. We're going to be remaining on the screen for the majority of the presentation. So you can post your questions there, and if we don't address it immediately, it's because we're gonna wait to that point. If not, we'll answer it towards the end. Okay. So go. I guess we're ready, Jorge.
Mhm.
Let's go ahead and talk about Eagle libraries and how to build your own components. Okay.
Okay, so welcome everyone to this First Flights webinar for building your own Eagle libraries. Today, this is going to be the first of a few webinars. We're going to make a simple component, a single gated component is our goal today. So this is the Eagle control panel, which you guys are already familiar with. Let's go ahead and hit File, New, Library. This will bring up the library editor in Eagle. Okay, as you can see, the three columns if you're used to from the version 7 series. And the first thing we're going to do is we're going to go ahead and start by building a symbol. So let me click on symbol. I'm going to put in a name for it. I'm going to call it an LM7. Let's just call it op amp. Let's be more general. Say OK. There we are. Okay, so this is our basic symbol. Now a couple of things we want to keep in mind for the symbol. First off, it does not have to be an exact replica of the physical package. It is only a symbolic representation, therefore you don't have to concern yourself too much with, getting all the pins in the exact locations that the package would have them. Okay, so let's go ahead. First thing I want to bring up is this grid. By default, it's 0.1 inches. For the schematic symbol, we strongly encourage our users to stick to a 0.1 inch grid. For the package, for the layout side, you can use whatever you want. But for the symbol, you should stick to a 0.1 inch grid. The reason for this is that all of the parts in Eagle's libraries are made, all of the symbols in Eagle's libraries are made to a 0.1 inch grid. Now with the new pin snap feature, this has become less critical. However, just for the sake of convention, and having all of the parts look uniform, we still encourage users to stick to a 0.1 inch grid. Okay, so we're going to use the LM741 as an example. And what we're going to do is we're just going to draw a basic op amp symbol. In general, you want to center both your symbols and your packages around the origin, which is 0, 0. And if you can't find it, just look here at the coordinates, and just move until you hit 0, 0. Okay. Now I'm going to go ahead and turn off the grid. I don't care to have it for this. Okay. And let me at least leave it at the dots. Let's do that. The dots is okay. Okay, cool. So what we're going to do now is we're going to go ahead and draw it. We draw it on the symbols layer, which is what it defaults to. And I'm just going to go ahead and kind of make the op amp symbol kind of freehand it. Okay, perfect. And notice that I made sure to land on grid dots the whole time. So now we're going to go ahead and put in some pins. Let's use slightly shorter. Let's use this one. Okay. That one there. I'll put this one there. For now, let's not worry too much about what's being written in. Okay, and I'll put this one here too. And that one there. And yeah, it's getting really messy. But don't worry, we're going to go ahead and clean that up. So first thing we're going to do is obviously change these names, the names of these pins. Whenever you see a $sign anywhere in Eagle, that is a default value. That is a value that was assigned by Eagle. Users usually will not use a $sign. In fact, I've never run into a user who purposely used a $sign. So whenever you see that, if you see that in a library part, if you see that in a reference designator, that basically means that no one took the time to rename it. So let's go ahead and rename this to the inverting input. We'll do that. Non-inverting. Okay. We'll name this plus V. And we'll name this one minus V. And this will be out. Okay. So right now this is looking pretty bad, right? Just very messy, very unclean. Let's go ahead and start to clean some of this up. So what we can do here is using the info command. Let's click on the output. Now in the case of the output, we don't really care to see the word out. So there's this option here called visible. And this controls what shows up on the schematic. So by default it is set to both, which means it will show both the pin name and the pad that it connects to. In this case we don't need to see the pin name, we only need to see the pad that it connects to. So we'll switch this to pad, we'll say apply, and you'll see that immediately the name goes away. However, we don't see the pad. The reason for this is that in the symbol on its own, a pad hasn't been defined to it yet, so we don't see it. Once we get to making the device, then you'll see that there will be a little pad number right here. Okay, so let's go ahead now and adjust these a little bit. The actual location of this text isn't user modifiable. So if that's the case, how do we clean this up and make this look nicer? What we're going to do is we're going to actually hard code the text in. So we'll say V+, we'll put it on the appropriate layer, and using the Alt key I can really finely place it. I'll do V minus. Actually, I put them in the wrong spot. Let's use move. Let's put this one right there. Let's put this one right here. Again, I can always, using the alternate grid, kind of line them up. Okay, that's perfect. Again, we'll use the same idea here. We'll just leave it to only show the pad. Okay, we can do something like that. Now the plus and the minus sign here could look better, so we'll go ahead and do that as well, just by hard coding in the text. So I'll put this where I feel it looks nicer to me. Plus, there. Now, just so I show you another way to do it, you can use a change. Select visible and just pad only. Now I can click both of those and it'll clean them up. Okay, the other thing we want to add here, text-wise, are greater than sign name. Put it on the names layer, make sure to do that. And then greater than sign value. These are just placeholders. When the symbol is brought into a schematic, Eagle will populate it with the appropriate values.
Hey George, the value needs to go on the value layer.
And let's go ahead and fix the value to values layer. Here we are. Okay. Now, this particular part also has 2 additional pins for offset nulls, which are almost never used. But let's go ahead and put them in because we want to make sure that our part is generally usable. Now, in this case, we could probably see that it would be good to maybe increase the size of the symbol. So what we're going to do is we can use the move command to kind of stretch it out a little bit. And we'll just go ahead and move these guys over. Okay, perfect. And then what we can do is we can add the offset null pins over here. Do something like that. Or we could try to put them on the same side. That's another option as well. So probably for this use case, maybe the best option is to put them on the same side. So that's what we'll do. We'll go ahead and move this one over here. You can see I'm iterating a bit, kind of playing with how I want this to look. Now notice that I left this kind of short, and I have a few things I could do in that situation. I could, for example, just draw a line. Make sure it's the proper thickness. In this case, it'll be 0.06. And if I click here, make sure it's on the right layer too. I can do an Alt, bring it in, and do the same thing here. And it looks like it's just part of the component. So again, we're going to name these. And I think what I'm going to name these is just no. This will be no at 1. Let's say the at directive allows both pins to have the same name or to show the same name on the board. Sorry, on the schematic. Because Eagle still requires that every pin have a unique name. So the way we get around that is by tacking on the at symbol. Okay, it's not critical. You'll also notice that in this case, because I had previously already made the change so that only the pad would be visible, these don't even show the names. So Eagle remembers when you make changes to the pin names. So for these, let's go ahead and put in some text just so that they do have a name. And I'll say no. Here, on info, maybe put that, rotate it like this. Maybe a little bit smaller too. Again, I can kind of move it however I see fit. Okay, and then once they're assigned on the device, then they'll show the pad names. Okay, so we could say that our schematic symbol is done. There's one other step that you can take if you want to, even though it's not strictly necessary, and that is to define the I/O directions for these. So by default, everything is an input and output. It doesn't really have any electrical rules checking to them. However, if we assign certain directions to, and then we can benefit from the ERC. So again, we can go change and say direction, and I'm going to pick an out. We'll make this one an output. We'll go back to the change command. For direction, we'll make the V plus and V minus powers, and then we'll make everything else an input. What this will do is it'll allow us to benefit from some electrical rules checking. So that's it for the symbol. You could take it a little bit further. You could go into the description, write some datasheet information. You could put a link in the description. You can use some basic subsets of HTML. So you can link images in. You can do tables. You can do things like that in the description if you were so inclined. But for our purposes, this should be enough for a basic symbol. So now let's go ahead and make a package. We'll call this, we're going to make the dual inline package. Yes. Okay. You're going to have the grid on here. I'm going to go ahead and turn it off. Or switch it to dots. Let's switch it to dots. Okay, perfect. So what we're going to do here is a similar idea. Now for the package usually is what will take the most time to do, because this does have to match physical reality. So in the package, you can set the grid to be whatever you want it to be, whatever's convenient. Usually, half to a quarter of your pin spacing or your SMD pad spacing will give you enough wiggle room to place everything easily, but still have control to define certain features. So the recommendation is set the grid to be half to a quarter of your pin spacing, depending on your needs. So before I actually make this, I want to make you guys aware of what you could do to avoid the process of having to make it. So I encourage you always, when you're going to make a part, to search to see if the package is already in Eagle or a package that is similar to what you need is in Eagle. The best places you can search are the reference packages libraries. So in the LBR field, go to ref packages and ref packages on pad. These contain only packages, and they will usually be packages that are standardized. So you'll find most of the standard packages here. So like the one we're going to make, which is a dual inline 8, you'll find that one under DIL 08. This is basically the package we're going to make right here. Okay, so I could just right click and select copy to library, bring it in, and I would already be done. So I encourage you, when you're making your own parts, search here first. Now, even if you do have to make the part yourself, there are ways to help yourself out. Okay, so let me go ahead and go over here. This is the data sheet for the LM741 that we're making. Here are some of its key dimensions. And using this information, we're going to go ahead and place our component. Now, if we look here, usually it's okay to just have the separation between the two rows to be 0.3 inches. Okay, we could give a little more, give a little less, but 0.3 would be okay because we're seeing that the maximum is 0.430. You generally don't want to use that maximum. Standard footprints will actually usually use 0.3. That way you have good compression on the pins to make sure that they stay tight while you're going to solder. So the separation between the pins is 0.1 inches, which is 2.54 millimeters for those working in metric. And then if we look here, the pin thickness, or the pin width, according to this, is 0.53 millimeters or 0.021 mils. Usually, if you're not given a specific drill size for the pad, you want to give some cushion around the pin dimension. So given this pin dimension here of maximum size of 0.021 inches, it's okay to add 10 mils on top of that. You know, that'll give you a good margin to be able to put in the part comfortably. Okay, so instead of 0.021 for my drill, I'm going to use 0.031. Okay. because and also I can do that because I have so much separation between them. So let's go over here to our library. Now in this case we have the grid set up, and it's actually pretty nice because we're at a half of a pin spacing. So let's select the pad command. I like circular pads. I already, by default, it goes to 31 mils approximately already, so we can leave it as is. And in this case, it's going to be very simple, because if we're doing 0.3 and we want to center the part around the origin, then everything is a grid multiple. So we would have one here, one here, one here, one here, right? Because this here is 0.15 inches, and we have 0.15 inches here again. Okay, and at a bare minimum, this is what you would need. Obviously, we're going to add a lot more. Now, this should make it very clear that how you set up your grid can make your life very easy, or it can make it very hard. If I would have had my grid set up to some random number, then obviously I wouldn't be able to get away with doing this. Okay? If that were the situation, there are some tools that can help you arrange the pads. So, for example, you can go to the UOPs and go into the ones that come with Eagle, obviously. Okay, and one here that can be very useful is component array. So if we go, where are you, component array? Okay, if we go here, in this case, we can tell this is a rectangular array. We have 2 rows. We have 4 columns. I could start it at 0, 0 to make my life easy. Now, what's the separation? Well, in the x direction, the separation is 0.1 inches. In the y direction, we have 0.3. Now we can say that the prefix for these is $. And here, so that I make it obvious, I'm going to start the array at 0, 0. I can always group it and then move everything over. So I'm going to say OK. And you'll notice that we have basically the same arrangement. So for any funky type components that you might have, using component array can make your life easier in setting them up. Okay, and again, I could just do a group. Oops, sorry. Okay, and I can click and hold and drag it to that point. Oops, sorry. Choose the move, control right click, and bring it there. Okay, and now we're back where we started. Now, one thing we do want to make sure we do is that we number this properly. Okay, so again, like I said, we see $signs, so we know this is what Eagle assigned by default. What we want to do now is we want to use the name command to rename these. So we'll click here, we'll say 1, oops, 2. As you can see, it becomes really easy because the name command stays active. 4, 5, 6, 7, 8. Okay, so now they're all named properly, like we would want them to be. Now we can go ahead and put in some additional information. Now, one thing we generally recommend to add is a silkscreen. By default, it'll be on T-place. One key point here of when you're making a library part is always design the part as if it's going to be mounted on the top. Okay, because when you bring it into your design, you can always mirror it to the bottom. So by default, the view you want to have is you're mounting this component on the top, and that's how you're designing it. Okay, so we have here our wire. We're on T-place. And again, if we return to the datasheet, we see that we have 0.26 and 0.24. That's the width of the part. So let me go ahead and bring up the browser so you guys can see that. All right, that's our width, 0.26, between 0.26 and 0.24. and then its length can be between 0.40 and 0.355. So obviously lengthwise it's easier to put in the 0.44, and it's still a safe number because it's within the parameters. So that's a choice that you can make, and that's the one that I'm going to go with now. So we're going to go ahead and draw from here, let's say to here, and do the same thing over here. Again, because everything is on grid, we are getting between, we have 0.4 here, see? So 0.5, 1, 1.05, sorry, 0.5, 0.05, 0.10, 0.15, 0.2. And by symmetry, we have another 0.2. There's 0.04 between these 2 points. Okay? Sorry, 0.4 between these 2 points. Okay, I think that's pretty clear. Now here, I've exceeded a little bit that width specification that we have, right? Because we had 0.26. Now what could I do to fix that? There's a lot of ways to skin this cat, but the easiest one is to go Info, and we can just change the points here. Okay? So what we could say is, if we want to get 0.26, then half of 0.26 would be 0.13. So just change these to be 3. Okay? You'll see that it changed. And we can do the same thing here. Okay, I'm going to hit apply and you guys will notice that it will change. And there we go. We see okay. So this could be enough. There's always the option to maybe add a few more little lines here if you wanted to. But this is enough for this component to work and to have a good delineation of the space it occupies on the board. Now, the same way that we added name and value on the schematic symbol, we need to add it here. What I'm going to show you now is kind of a shortcut to bring those in. There's another UOP that ships with Eagle called set name and value. And using the power of Windows, if I can just type properly, you see right here set name and value. If you just double click it, it automatically puts it in and on the correct layers. So I'm going to go ahead and put that one there. Let's put this one here. Okay. And that's basically it for the package. This package will work as designed now. You can always add more details. For example, one good option to add here would be something to indicate. Let me make sure to put this on T-place. Something to indicate the orientation. So again, I'll use the Alt. And that will let the assembly house know in which orientation to put in the chip. Okay, because they can match the little rounded area with this. Again, for the sake of brevity, I've had to simplify the package design, but as is right now, this is going to be usable. Okay, so we have our symbol done and we have our package done. The only thing we need to do now is merge the two into a device. So let's go ahead and click on the device icon.
Hey George, before there, somebody was asking a little bit about arbitrary pad shapes. Can you explain it just a little bit about
Okay.
drawing the polygon on top of a pad and explain to them how it works? A few
Okay.
minutes there.
So probably in the next webinar we will be going more in depth into arbitrary pad shapes, but just to give the idea, basically the way arbitrary pad shapes works in Eagle is that either a pad or an SMD object defines the connectivity. Okay? So when you make the arbitrary pad shape using a polygon, within its borders there must be either a through-hole pad or an SMD. If there is, Eagle will consider the polygon an extension of that pad and therefore won't generate DRC errors on it in the board and when you make connections to it. Okay? So let's say, for example, this pad number 8 needed to have some weird shape. What we would do is, using polygons on the top and bottom, or on as many layers as you expect to use this part, you would draw the shape. So let me go ahead and use the Alt key and make something weird. Say it was something like that. Because there is this one pad in the middle, now Eagle considers this entire polygon to be part of that pad. Okay? Now there are a few caveats to this. Like I mentioned, you have to redraw this pad on the top and the bottom because this is a through-hole part. The other caveat, we'll see if I turn on the stop layers and the cream layers. So let's go ahead and do that. T-stop and T-cream. Okay, if you look, by default, Eagle generates an automatic stop mask and an automatic stencil opening for the pads, but it doesn't do it automatically for the polygon. So if this whole polygon needs to be exposed, which in most cases it does, then what you have to do is you have to redraw those features on the appropriate layer. So just following the same idea, I go T-stop, use the Alt key, okay, and then using T-cream. And this way you can guarantee that the whole pad is exposed copper. Okay, so that's the caveat, and it has to be done on both top and bottom. That's in a very quick little overview, that's how the arbitrary pads features work. So what I'm going to do now is I'm just going to remove these polygons, clean this up. Okay, and let's go ahead and make the device. Actually, before I do that, I want to show you one other thing. Again, besides the fact that you could import the package, you could also use Eagle's built-in wizard to create it. So all of this little effort could have been avoided if I used the wizard. Now the wizard is called Make Symbol Device Package BSDL. Now this is a very, very powerful UOP. And it has a lot of different functions that you can incorporate into it. It's also one of only 2 UOPs in Eagle that ship with a manual. So it gives you an idea of how powerful it is. Okay, so if let's say we wanted to automate the creation of this package, what we would do is we would click on Package. Okay, we would put in the parameters. These are in millimeters. I could change it to inches, whatever inch I wanted. So let's say inches. And then what we're going to do is we're going to say dual, because that's the type of package we want. And we're going to go ahead and put in these dimensions that we got from the datasheet. Okay, so following that information, we can go ahead and put this in. So E is going to be 0.1 inches. The thickness of the pins itself, B, is, oh, sorry, gotta pick pad. There we go. The thickness of the pad itself is B. So we'll select for that 0.021. Okay, the M value doesn't play anything in this one, so I can leave that at 0. I have E, I have B. Okay, we have D1, we already know is 0.4. And then this other thickness, sorry, D1 is 0.4. D
Just
is,
to let everybody know, we're getting the values from the spec sheet that we
yeah,
haven't printed out here. So that's how we're getting the values to fill in
yeah,
the
yeah, right here.
criteria.
I'm just using these. Okay, I'm grabbing from here. It would just be hard to constantly flip back and forth, and we've already run over a little bit, so I'm trying to respect everybody's time. Okay, the length of this, again from the data sheet, would be 0.43 max. Now for R, the annular ring that we want on this, let's say for our purposes should be 0.01 for 10 mils. And then X, which is the diameter that we want. Remember how I said we would use 10 mils more, we can just do 0.031. Okay, I don't believe any other parameter needs to be done. Here, I'll generate a quick pad list. Say 8 pads are automatically created. Now here we filled in everything that we needed to. Whatever parameters aren't included in this drawing will be ignored. And then all I have to do is accept parameter. No name defined, okay. Let's give it a name. 08, I'll call it Wiz. This was made by the wizard. I'll go accept parameter. Come on. Okay, Wiz. I'll accept the package name. Now we go over here, click accept parameter. Now it's happy. Whoops. And we hit OK. Okay, let's make it in the same one. Made it in the same one. Wasn't that horrible? Ours is okay, so that part was fine. Don't know what happened there.
I think we need to cover this maybe on a different
Okay,
UOP.
so we'll leave this for the next one. Sorry
Yeah.
for the issue with this one
Now,
in this
George,
case.
can you? Just one person is asking if you could just demonstrate the dimensioning tool really quick here
The
in the
dimensioning
library.
tool? Sure.
Yeah, just really quick here.
Okay, normally you won't add dimensions, but what you would do in this case is activate the dimension tool. We normally encourage you to put the dimensions on the measures layer. Now one option is to just click on an object and it'll automatically dimension it. So we have that, or let's do this one. What's going on here? Let's make the font much smaller. Okay. Do it over here. Increase to any size that I want, but normally, there we go. Okay, and depending on how I move, then it will adjust. So I can also use an Alt, use a finer grid. That'll make things a little bit easier. Okay. You can get a radius, you can get the different arcs. Something like this.
So the behavior works exactly the same way it works on the board layout. It actually will snap to the element that you're selecting to. Just wanted to demonstrate that.
Yeah. Now if you didn't want it to snap, you could hold Alt and just anywhere that there was appropriate grid unit, it would snap to. Okay. Okay, so that's basically it for this part. Let's go ahead and switch over to the device. Go ahead and name it LM741. And now we will go ahead and add the appropriate symbol. Again, you try to center it. You could add as many as you want for a multi-gated component. We'll be covering that next time. I'm going to put in a prefix. I want this to be an IC, so whenever I bring this into the schematic, we'll have IC1, IC2, IC3. I'll select my package. Okay. And now this value part here requires some explanation. If we set value off, Then when I bring this into a schematic, the value will be the device name, which will be LM741. And in this case, and for most ICs, that's what you want. If I set it to on, then the value will be completely user definable. So in this case, we'll leave it off because that's what we want to see. We want to see LM741. And the final thing we need to do is just connect it. So again, going to the datasheet, here we can find all the associations. Okay, so going off of that, I'll go ahead and connect them. Okay, so this is... Now what I usually like to do is I'll select one here and leave the pad alone. So pad 1 is an offset null. I'll connect it to that. Pad 2 is the inverting input. You notice how it's just going down. Pad 3 is the non-inverting input. Pad 4 is the negative supply rail. Pad 5 is the other offset null. Pad 6 is the output. And pad 7 is V+. And we have a leftover pad that is a no connect. Okay, now it's okay to have leftover pads. What you can never have left over are pins. Okay, you can always have more pads and pins, but the inverse is not allowed. So we'll say OK, and that's it. This part is done. It's ready to use. I'm going to go ahead and save this library.
Hey George, could you just go back just 2 seconds and explain what a pad to when you're doing the connect and you append multiple pins to one pad?
Bear with me 1 second. Save it. So we go over here to connect. So someone asked for doing multiples. Okay, so
Just a quick explanation.
just a quick explanation of it. Basically, you can assign multiple pads to a single pin. So let's say that here this other null is 5. We'll connect that. And let's say that for the output, we want both 6 and 8 to connect to it. So what we could do is you could here hold shift and you have 2 pads selected. If you say connect, you'll get them like this. Another option is to, if you only have 1 selected, you could say connect and then after the fact say append, and it'll tack it onto the last connection that was defined. So it gets you to the same result. And then here you can individually disconnect them. So we know like 8 is a no connect, so we can individually disconnect that one. And then we'll know it's just pin 6. Okay.
That's good. He's good.
So I'll leave it at 6. I'll leave that. Okay. Again, in a future webinar, we'll go over more complicated parts. The goal of this webinar was to do something simple. So I'll go ahead and save this now. And now, just to prove that it works, we'll start a new schematic and make sure the library is in and being used. So I'm just going to refresh it and make sure that the LM741 library is in use. So here it is. We click the green dot to put it into use. Then we go into the schematic. We go add. And we'll find it here, LM741. Say OK, and there it is. And we can put in as many as we want. And again, you guys will notice that now all of the numbers show up as expected. Okay, in this case, to make it look a little bit better, I could have just pulled this away a bit more and the numbers would have shown up like they do here with the nulls. Okay, so that was it for this webinar. Thank you very much for joining us. I think Ed's been fielding the questions, but if there's any other questions, I'm more than happy to answer them.
There was just one question, Jorge, in regards of conventions when it comes to prefix. So you were using IC, but there's also conventions for U as well. Can you tell us just a touch about that?
So conventions are in general standardized. especially for passives like resistors, inductors, capacitors. But for integrated circuits, that can vary, and for connectors as well. Some people like to use the letter U, some like to use IC. For connectors, sometimes you'll see J's, or you'll see the actual CON. It all depends on the convention of the person who's making the part. But again, it's mostly standardized. You won't see too many crazy things. I've seen, for example, transistors generally are Q's, but even then I've seen some people use T's for those. So in general, there is some pretty strong conventions, but they're not written in stone like some other aspects of ECAD are. So you could use whichever one your team will understand best. Most people can tell, IC and U, and they can follow it. I hope that answers the question.
Okay, cool. So I don't really have any other questions to cover right now. We basically covered them throughout the presentation. Yeah, we will have, Charlie, yes, we will have some more webinars. We're going to have one webinar dedicated solely to the ULPs, which are great tools to use. We wanted to show you all the steps to do it manually, because the intention behind this webinar was really to teach you the taxonomy of how the library is created. That way, if you need to build one or you want to download one and you want to be able to understand all the terms that are necessary to make sure that the one that you want to use is correct, or you need to correct it, we wanted to give you those tools to provide you that as well. So, um, hey, everybody, we understand we went over the time, but so basically what we wanted to cover was what is a library? What does a component consist of? It consists of a symbol and a package. Your symbol, make sure that you usually placing your pins on a 0.1-inch grid. As you could see, we were using the right mouse key to rotate the parts in 90-degree increments, as well as there's multiple sizes that could be used. Now there's one distinction that I want to bring up here is for each pin has a visible parameter. In other words, I could have it see the name of the pin as well as the pad assignment. I could be both. It could be only the pad assignment. It could be only the pin name for it, or it could be neither of them. A very useful tool, but many times the naming of the pin cannot be moved around. So for then, you may want to disable it and manually put it in using the text command. On the package level, please remember, it's paramount that you're using the appropriate grid. So always find a common denominator grid that will satisfy the placement of your pads. It is so important that you use the appropriate grid. Once you have your package and your symbols created, and then go ahead and move on to the device where you're going to bring in your package, you're going to bring in your symbol, assign which pins go to which pad, provide it some sort of a prefix that makes sense to you or logic to the component. And also remember, when you're in the device level editor, you could assign attributes. The attributes for the component can include most probably who is going to be your provider, or it may be some internal database numbering system that you may use yourself. Thanks for your participation. Thanks for the questions. Thanks for your comments. I think it went really well. We went over the time that we had allotted initially, but we'll make the recording available to everybody in the future. Okay. Thank you and have a great day.
Thanks, guys. Have a great day.